Physics 211 Lab 1 Charged Tapes by Swam Sanket Kumar Trivedi. Introduction. Purpose. The goal of this lab is to observe the interactions between charged pieces of tape and determine the amount of excess charge present on them. This experiment shall be done using the following materials: clear tape, ruler, flat surface, and supportive materials. The method I used was a closed script simulation through which I simulated the tape and the forces acting between the charged pieces. Fundamental principles used: Newton's second law, which states that a net force acting on an object is directly proportional to the rate of change of its momentum for constant mass. It simplifies to force being proportional to acceleration. Second, Newton's law of universal gravitation or gravitational force, which describes the attraction force between any two objects with mass. This force is proportional to the product of the masses and inversely proportional to the square of the distances between their centers. Coulomb's law, which describes the electric force between two charged particles. The force is attractive or repulsive depending on the signs of the charge and is inversely proportional to the square of the distance between them. Preview of the main results. The results of the experiment showed that the charge of the tape was 1.167 e to the power minus 8 coulombs, and that the number of electrons lost by each tape was 7 times 10 to the power 10 of electrons. Here are the main physics ideas where each formula has been described: Newton's second law, gravitational force, and Coulomb's law. These are the formulas we'll be using throughout the presentation and for the closed script model. Some of the initial conditions include the mass of the tape, which was 2 times 10 to the power minus 4 kg, the tape dimensions, which was 0.2 meters for the length and width, the tape area, which was 0.004, the atomic cross-sectional area, which was 1 times 10 to the power minus 20, and the number of atoms on the tape surface, which was 4 times 10 to the power 17 atoms. So this is the observed model and how it looked. Tape A was below and tape B was above, and the two separate tapes are separated by a distance d. So the system is tape B and the surroundings are tape A and everything else, like my hand and stuff like that, and the distance between the two tapes is 0.025 meters. I then calculated the excess electrons by using the gravitational force formula, the electric charge, calculating its electric force, and then the number of electrons lost by dividing the charge of the tape over the charge of one electron to get around 7 times 10 to the power 10. I then found the ratio of atoms over electrons to get 5.7 times 10 to the power 6 atoms per electron. This is my computational model for experiment 1 and the results I obtained. So towards the right topmost, that's my closed script code, and this is the formula I used, and the charge I got was 1.21 times 10 to the power minus 8 coulombs. I then plugged this into the computational model for experiment 2, and the mass of tape was inputted, and the estimated net charge of one tape was kept, and then I did this. These are the results I obtained. Towards the furthest left is the diagram that was created, and towards the right, the results I obtained, which was the charge of a piece of tape is 1.16726 e to the power minus 8. The number of electrons lost on one piece of tape is around 7.28628 e to the power plus 10. There are 5.48977 e to the power 7e plus 6 atoms for every direction lost on one piece of tape. Electric field at point B due to tape A is 0, and then 1.68086 electrons plus 5, 0 newtons per coulomb, and the electric force on tape B is 1.962 electrons minus 3,0 newtons. The assumptions and errors I made during this experiment include: the assumptions are air resistance and friction were considered negligible. The long tape can be treated as a point charge, and each piece of tape has an equal and evenly distributed charge. The limitations and sources of error include unequal distribution of charge on each tape and the loss of charge due to handling or environmental factors. What if electrons and protons had opposite charges? All of the observations made during the lab remained unchanged. Even though the pieces of tape would now carry negative charges, they would still repel each other and be attracted to the now positively charged pen. Why? What if you compare the point charge model and the line charge model? The two values for charge would be different because the point charge model assumes all the charges is connected at one point, which isn't realistic for the tape. The line charge model separates the charge along the tape, which is more accurate, so the line charge model gives a value closer to the real charge. Thank you.